This is Mrs. Naslund, and today we're doing Unit 1, Lesson 1, Solve Word Problems with Tables. Our learning target for today is I can interpret data tables or data displayed in a table. So the idea is we're going to look at tables, we're going to practice reading them, and then later on in your remembering, you'll work on actually creating a table as well. So here's what it says. Jonah collected information about the type, weight, and lifespan of several dog breeds. Information like this is data. Jonah organized the data into a table. A table uses rows and columns to display information. So if we look at this chart right here, if you look at it, it shows the breed of dog, the type of dog, the average weight in pounds of the dog, and the average lifespan of the dog. So remember, data is the information that's collected. We display that data in the table. We show it in the table. Rows go horizontal across like this, and columns go up and down. So with that in mind, let's go ahead and try to answer the first question. It says, what is the average weight of a Dachshund? So first thing I'm going to do is I'm going to look and see if I can find a Dachshund under the breed. Oh, there it is. And then I've got to find the one that shows me the weight. So we have the type of dog, it's a hound, and there we go. The average weight in pounds is 24. So a Dachshund weighs about 24 pounds. Number 2 says, which breed in the table has the shortest lifespan? So I'm going to have you go ahead and work on that one. I know that the table is a little small here, so I'll try to make it a little bigger so you can see it. So we're looking for which breed has the shortest lifespan. So we're going to be looking at the breed, and then you're going to be looking at the lifespan and see if you can figure out which breed has the shortest lifespan. All right, so we look here, and shortest, we're going to look for the smallest number. So in this case, the smallest number is 7. So Great Danes have the shortest lifespan. There we go, Great Danes. All right, let's keep going. It says, which 2 dogs are sporting dogs? All right, so I'm looking at the breed here, and then I'm looking at the types of dogs. I'm looking for sporting. There we go, we have a Labrador Retriever and a Cocker Spaniel are sporting dogs. All right. And the last question says, let's scoot it over here. Hopefully we can get it to show up. A little slow, sorry. The last question says, here we go, go that way. All right. What is the difference in average weight between a Great Dane and a Jack Russell Terrier? So we're looking for the difference in weight. Now remember, difference means subtract. So we want to know the difference in weight between a Great Dane and a Jack Russell Terrier. So we'll bring this back over so you can see all the information again. A Great Dane and a Jack Russell Terrier. So let's go ahead and look. A Great Dane weighs 115 pounds. We'll write that down. 115 pounds. And there we go. The Jack Russell Terrier weighs 12 pounds. There's a big difference in weight in those 2 dogs. So again, difference means subtract. So we're going to go ahead and subtract those. 5 minus 2 is 3. 1 minus 1 is 0. We just bring down the 1. So there's a difference of 103 pounds between the Jack Russell Terrier and the Great Dane. All right. Next, we are going to look at function tables. And we talked a little bit about this in the fluency chapter, but we're going to kind of dive a little bit deeper into it. So functions can be shown in a table, a graph, an equation, or in words. When a table is used to show a function, the rule is shown in words at the top of the table. And the input value x is the first column. The output value y is in the second column. The equation at the bottom of the table shows the rule in an algebraic way. So this is a function table, okay, a completed one, and X is the input. Think of it kind of like a machine. This is what you put into the machine, and Y, the next column, is what you get out of the machine. And the question is, how did you get from X to Y? Okay, and in this one it tells us, it says add 2 to X. So I put a 0 into the machine, I add 2, and my output, or my Y, ends up being 2. Let's try another one. If I put 5 into the machine, and I add 2, my output ends up being 7. So the equation that I would write is that Y, so these numbers here, are equal to X plus 2. So 11, for example, let's pretend, if I put 11 here as Y, 11 is equal to 9 plus 2, which it is. Okay? So it says, above each table, write the rule in words. After completing the table, write an equation that represents the rule. So a couple of things when you look at input-output tables, or the little machine that I like to call it. If the number is going up, okay, so from my input to my output, if the number is going up, so in this case it's going from 1 to 5, it's going up. There's only two ways we can go up in math. We can either add or we can multiply. Okay, so in order for it to go up, I'm either adding or I'm multiplying something. Now, if it goes from my input to my output and it goes down, okay, if the number actually goes down, the only way to go down is either to subtract or to divide. This is really important because this helps you figure out right away. You can eliminate two of the choices when you're trying to figure out what's happening, what the machine is doing to move from the X to the Y. So let's go ahead and look at this first one. It's going from 1 to 5. Okay, so is it going up or down? You're right, it's going up. Okay, so I got to think, how's it going up? So there's a couple ways it could go up. I could add something. If I added something, I would have to add 4. 1 plus 4 equals 5. Okay, if I was going to multiply something, I'd have to multiply it by 5. 1 times 5 is 5. Now, how you check that is you go to the next one. So now I'm looking at the input of 2 and my output is 6. So let's go ahead and try. First we said let's add 4. So if I say 2 plus 4, hey, it worked. I got 6. Let's try the multiplying. If I do 2 times 5, like we would have had to do, I would have got 10. Does that work? No. So now we know that we've added 4. Let's check one more to make sure we're right. 5 plus 4 equals 9. Does it work? Yeah, it does. So at the top here, I'm going to write my rule. And basically my rule says that I'm going to add 4 to X each time. So let's go ahead and try to fill in the blanks here. So 3 plus 4 equals 4, 5, 6, 7. All right. How about this one? I'm going the opposite way. So what number would this be that I'd have to add 4 to get 8? You said 4, you're right on. Another way to think about it is I have to go the opposite way. So instead of adding 4, I could subtract 4 because I'm going from the Y to the X. Okay? So now this is the part that kids normally struggle with. Well, Mrs. Naslund, okay, so I figured out that I have to add 4 to X, but how do I actually write that as an equation? Well, remember we want it to equal Y. We want to do something to X that equals Y. And what are we doing to X? What did we have to do? We had to add 4. So I'm going to say Y equals X, and what did we say we had to do? We had to add 4. So Y equals X plus 4. Okay? All right, let's try another one. This one, okay, we're going from 0 to 0. All right, so that's kind of hard because it's staying exactly the same, right? So I couldn't add anything. I couldn't subtract anything for it to be 0 equals 0. I could multiply. I could multiply 0 times 0 and I would get 0. But let's look at some of the other choices and maybe that'll help us figure it out. So 8 to 24. Again, it's going up. Okay, so again, if it's going up, my two things could be, is it adding or is it multiplying? And we could try to figure out the difference. So the difference, what would I have to add to 8 to get to 24? If I was adding, I'd have to add, let's see, 24 minus 8, I'd have to add 16, okay? I have to add 16, or, I'm going to write that down, I could maybe be adding 16, or what's another way I could get there with multiplying? Instead of adding 16, I could multiply it by 3. So I could be timesing it by 3. So let's go ahead and try the next one and see if it works. So 6 plus 16 is going to give me way more than 18. So adding 16 did not work. But how about multiplying it by 3? 6 times 3 equals 18. So it does work. So our rule is, in the machine, I'm going to put something in, I'm going to multiply it by 3, and the machine's going to spit out the answer. So our rule is multiply x by 3. So let's go ahead and try it. So 4 times 3 would give us 12. And I got to think about this one. I got to go the opposite direction, right? So what times 3 would give me 6? Or if you want to think of it the other direction, I could think about 6 divided by 3 equals what? So either way would work. What times 3 equals 6? Or 6 divided by what would equal 3? And the answer is 2, right? 2 times 3 is 6. 6 divided by 3 equals 2. So now we go to write our equation. We're going to always start with y equals. Okay, so y equals, and then we're going to put our x in, x, and then we put our rule in. They put 3x, which means x times 3. Okay, when you see it written as 3x, that's the same way as saying 3 times x. Okay? All right, let's do one more problem here, and then we'll be done. All right, so we're looking for a rule. We don't have anything there, so the number is going up. So I want you to see if you can figure out what the rule is this time. The number is going up, so think, are we adding something or are we multiplying something? So go ahead and look at the different ones that we have, both the input and the output for, and see what you think. All right, if you said multiply, you're correct. Because look, we do 3 times 5, we get 15. We do 5 times 5, we get 25. So our rule is we're going to multiply by 5. So let's go ahead and try to solve the rest of these. 7 times 5 would be 35. And what times 5 would be 10? Or 10 divided by 5 equals what? 2, right? And then how about this one? What times 5 equals 20? You said 4, you're right on. So now let's write our equation. We're going to say y equals, and then we're going to think, okay, we had to multiply x by 5. So they're going to probably write it like this. They're going to write it as 5x, okay? But that just means, again, 5 times x, or x times 5. Remember, we learned the properties. It doesn't matter which way we put it. We'll still get the same answer. All right, great work. Today we learned how to look at tables and interpret them, and then also started talking about input-output tables.